Ready? Okay. This be a new one. Seen her before. Yes, we are. Okay, so starting on page 859er, we're going to be on 13.2, which is defining central or general angles and using radian measures. This assignment, for instance, is not going to take near as long as the one that you had to do for me today, which a lot of you didn't get done. Okay, so therefore you'll have some time. Okay. Now the first thing that we're going to do is we're going to be drawing some angles. Okay. If I give you an angle of 240 degrees, we're going to have to draw that. Now, what happens is you use the coordinate plane, and you start right on that side right there. You start on the 0 degree is right here. And you go counterclockwise for positive. So therefore, when I go 240 degrees, if I go from here to there, how far have I gone so far? 90. And then when I continue to go on one more time, how many is that? 180. If I go all the way to this one, though, how far is that?
360.
No. 270. Because this would be a 90, this would be a 180, and this would be 270. That's too far, is it not? Where would the 240 go? Like in between it somehow. So somewhere in this vicinity, I should make a line that represents this going out here. I just drew the angle. Okay.
Did you just draw around? I remember doing this last year.
How did I draw that line in there?
Yeah.
Okay, no. What I did was I kind of physically thought of if 270 is that bottom line and 240, how far is that away? This right here is 30 degrees inside there. That's what I'm hoping. Is that about a 30-degree angle?
Yeah.
Yeah. Okay, I'm not going to make you or require you guys to go grab protractors and measure this out 100% accurately, but as long as you're in the ballpark vicinity, I'm going to give it to you. Okay? Are you okay with drawing the angle so far?
Yeah.
All right. What about if I were to give you the angle of 500 degrees? How many times did I go around? At least once, right? Because how many is one rotation? 360. So there's 90, 180, 270, 360. And if I go up to there, what's 360 plus 90? 450? 360 plus 90 is 450. So 500 would be how much more? 50 more degrees, which 50 degrees is just a little bit greater than half. So it should be right in there. Now, when you're drawing a 500-degree angle, when you're doing this, when you're putting it in a position like that, make sure you show that spiral to show me that it actually went around one full turn and then stopped at the 50. Okay? Are you guys okay with that so far? Can you draw those? Nick, what's up? 0 degrees always starts here. Always. Okay? And you always go counterclockwise when it's a positive angle. Okay? Now, if I were to give you a negative angle, negative 50 degrees, the 0 angle starts there. Now, if we're going negative, which way do we go? We go clockwise. Okay, so we go down this way. How far? 50, which is probably a little bit more than half. Is that about 50 degrees? Close? Okay. It is important that you put those little hash, like this little hash mark that I'm darkening in, a little bit darker green, so that way the reader knows that you didn't just go one full turn and then the 50, that you just went straight down there. Okay, that shows that person that that's what you did. Okay? How are you guys with graphing these so far? All right? Not so bad? Okay, good. Because in your assignment, that's a lot of the different pieces or whatever that you're going to be doing. Now, a couple different things, just so that you guys know, they have some key terms on the top of page 859. They talk about the initial side and terminal side, and then they talk about in standard position and so on. Just so that you guys have this labeled, this right here would be known as the terminal side. Why is it known as the terminal side? Why do you think? It's where it stopped, right? Isn't terminal means stop, so to speak? And then the initial side is where you started. Okay? And then when it talks about standard position, it says there, an angle is in standard position if its vertex is at the origin and its initial side lies in the positive x-axis. So this is in standard position. Vertex is right here at the origin. The initial side is at 0, which it was. So that's the angle in standard position. Back here, when I did this one, this would be the terminal side right there. This would be the initial side. And it is in standard position because we went around one full turn plus the whatever we had to go. Okay, same thing with this one. Terminal side, initial side, it's in standard position. Okay? So if they ask you for that, just remember that positive goes counterclockwise, negative goes clockwise. Does that make sense? All right. Now the next thing that they're going to have you doing is they're going to have you finding what they call coterminal angles. And what coterminal angles are angles that will help you find those positionings. And like that one that I had that was where it was 30 degrees, so I tried to make that 30-degree mark there. Right? That one that was in quadrant number 3, where I made the 30-degree mark. That's one of those angles that tries to help us out. The directions that they're going to have for coterminal angles, it's going to say find one positive angle and one negative angle that are coterminal with negative 45 and 395. So they want one positive and one negative. Now, here's what you do. To finding this, and please don't make this any harder than it has to. To finding one positive coterminal angle, I want you to add 360 degrees to it. Why 360? That's a full turn, right? What's negative 45 plus 360? 315. Now, if I want to find one negative to it, I add negative 360 to it. What's negative 360 mean? That just means I'm going to go clockwise one full turn. What's negative 45 plus negative 360? Negative what? Negative 395. Now, if I were to graph all three of those degrees. All right, well, Hannah, I'm done listening to you. Okay? Now, if I were to graph all three of those angles, okay, and I'm just going to erase this 395 thing over here because we'll deal with that one here as example number 2. But if I were to graph all of them, -45-degree angle or negative 45 should be right here, shouldn't it? Is that about a negative 45-degree angle? If I go 315, that means 90, 180, 270, and another 45. That's also right there. If I were to go back 405, that's negative 90, negative 180, negative 270, negative 360, and negative 45 more. It's also in the same positioning. Every single one of those has the same position. They have the same terminal side. So when they want coterminal angles, they want angles that have the same terminal side. That's what they want. So they're going to ask you to find one positive and one negative. All you got to do is add 360 or subtract 360. It's that simple. Do you have to draw them? Not necessarily unless it says to. If it asks you to come up with one coterminal angle and one positive and one negative, just add 360 or subtract 360. What if I say one positive and one negative and my answer is bigger than 360 and I want a negative one? So let's say I had the 395. If I had 395 and I add 360 to it, first of all, that's one coterminal angle. What's 395 plus 360? How much? 755. But if I take 395 minus 360. What do I get? But I asked you for one positive and one negative. I don't have a negative one there yet, do I? So what could I do? I can't hear you, Denise. Subtract 360 again. And what would I get then? Negative 325. Now, just so that you guys are aware of this, and I will take both answers, but this and this would be the answers that they will give you. Okay? As far as if you looked at the answer in the back of the book, that's the two answers that they would want you to list. They would want you to list the 35 and then the negative 325. That's what they have as possible answers. However, are those the only answers you could have? No. Obviously, if I found that one, it didn't specify how big or how small, did it? Could I keep subtracting 360 to find smaller ones? Right? Or 720, because that's two turns. Okay? So I could keep going with all those if I wanted to. All it asks you to do is do one positive and one negative. Now, what if it said within a certain range? Then, could this one possibly not be an acceptable answer? Yeah. Okay, so just pay attention to the range. But if it says coterminal angles, all I'm doing is trying to find angles that would have the same terminal side. That's what I'm trying to find. I'm adding 360 or I'm subtracting 360 as many times as I need to. What do you think of that so far? Do you want to do another one of those? Okay. So if I gave you the angle of 740 degrees, and I said one positive, one negative. Danny?
Hi. What kind of plant do you want?
I don't care.
Okay.
You pick. Yeah.
Cactus. Get a cactus.
All right. So if I've got 740, okay, Hannah, I want one positive and one negative. That's all I want. So for this particular thing, if I add 360, what's 740 plus 360? That's the positive one. As far as negative goes, though, if I were to subtract 360 and subtract 360 again, I'm still at positive 20. Right?
Negative 340.
So I would subtract 360 one more time and get negative 340. Now, Hannah, just so that you guys know, this is the part that is good for you, bad for me. Negative 340 is the first negative one that we could have for that. However, could we have more if we just kept subtracting it? Absolutely. The positive ones, we got 1100 just by adding it. However, if you would have subtracted 360 and got an answer here, subtracted 360 and got an answer here, I have more answers. Which ones are right? All of them, as long as they don't specify a range. Now, Hannah, if it were to say I want numbers that are in between the absolute value of 0 to 360, then I want the 20 and I want the negative 340. But if it doesn't specify, you don't have to tell me. You can tell me any of those. Does that make sense? Unless it says to draw it, you don't have to draw it either.
For your positive, you use 20 instead of 1,100.
Yeah.
So you just put those three numbers that you answered?
You wouldn't even have to have the three. One of the positives and one of the negatives.
You don't have to draw it?
Unless it says to draw it. Okay, now the next thing that is going to be coming up that is important in this section is dealing with radian measure. Right now, all you have ever done in your math careers has been in degree mode, like the triangle and sometimes circles. Okay, but radian measure is a huge thing when it comes to trig functions, and I'm going to give you some formulas now on how to convert from degrees to radians and vice versa. Okay, so when you're going from degrees to radians, what you do is you multiply, so you take the degrees, multiplied by pi radians over 180. Yep, if I want to go from a degree measure, which we know how to do, into radian measure, I multiply that angle, whatever it happens to be, multiplied by pi divided by 180. The radian is just a label. like meters and centimeters would be. Okay? So let's use one of the angles that we just had. 20. That was one of the answers that we just got on that one. What's 20 as radian measure? I take 20 times pi over 180. Now if I go straight across, I'd put the 20 over 1. 20 times pi is 20 pi. Do not multiply that out unless it asks you to round to a certain decimal point. Just leave it as the pi symbol. By the way, happy belated Pi Day. Then 1 times 180.
6 days ago.
I know, but we haven't really been in class. You're late. Then, on this particular thing, now all I have to do is reduce 20 over 180. These cancel each other out. And 2 over 18 reduces down to what? 1 over 9. So 1 pi over 9. That's the radian measure of the 20-degree angle that we found for Hannah's coterminal angle. You don't have to put the 1 in front of there. You can if you would like.
What about that radian?
Okay, I forgot to label it as radians.
Oh, alright.
And just so in case you're not aware of how to spell that, you can abbreviate it by just putting rad.
Radical D.
Rad, bro.
Yeah. Okay? So, give me another degree.
17.
16, actually.
Let's go 16.
Why?
Just because.
Better number.
Times pi over 180. Then I would put the 16 over 1. Go across the top. 16 pi over 180. Does 16 over 180 reduce? If you're not sure how it reduces, all of you guys have calculators that will do it for you. If you have your TIs, all you do is you take 16 over 180, hit enter, it'll give you a decimal, and then you hit math fraction, and it gives it to you. What is it? So it's 4 pi over 45. Yes, you do have a pi button. But it does not give you, it gives you the decimal equivalent, Markel, to what pi is.
So you'd only use it if it asks.
You'd only use that button if it asks you for, like, to the nearest tenth or hundredth. Okay? All right, what do you think of that so far? Just converting? Okay. Now, from after that, you're going to do from radians to degrees.
I can't get that answer.
Now, the reason why I ask you, or this one's important, is because they're going to ask you to graph radian measures. Now, me personally, I am not that great at graphing radian measures. I don't remember what they are. So what I do is I convert them into degrees, and then I can graph that no problem. Okay? So in this particular case, we're going to multiply the radian measure. So you have the radians. And you're going to multiply it by 180 over pi this time. So if I were to give you a measurement of pi over what?
6.
Pi over 6.
32.
Okay, so that was my number. Pi over 6 radians. I want to know what that is as a degree because I can't graph pi over 6. So what I do is I multiply it by 180 over pi, and this will give me the degree mode. Now, how I do that is, if I multiply straight across, I get 180 pi over 6 pi. What happens with the pi's? They cancel each other out, and what's 180 over 6? 30. So pi over 6 is the same as 30 degrees. Can you guys graph a 30-degree angle? Or represent it as close as you can, right? You guys know what a 30-degree angle is. You didn't know what a pi over 6 degree angle, or pi over 6 radian measure was. But now you do. Me personally, that's how I graph radians. They give you a circle. Just so that you know, on page 861, that circle is an important circle. Okay? That circle we are going to use more times than not. I would, if I were you, find one on the internet and print it out. Nice and big. Okay? That circle is important. We're going to use that circle not only in this section, but in all other sections. That's the unit circle that we're going to use coming up. Okay? So they give you all the different ones, and if you look at pi over 6, it actually is right on the red 30-degree angle. That's what they are. That circle is an important circle. Then, the last two things that they give you is they give you arc length and area of sectors. For those of you who had geometry last year, you would have had something like this. Now, a sector, just so that you guys know, did anybody have pizza last night for supper? Okay. Got a couple people that had pizza last night. You had a piece, right? Did they cut them in the triangles or did they have squares? Tomato and pepperoni? Okay. Which, did you know you were really having a sector of it? Yeah. Yeah, there you go. Pizza or pie. Okay. Arc length is on the circle. That's this part right here. That would be arc length. The crust. Right? Do you eat your crust? I do too. But some people don't. What you do is you take the radius and you multiply it by theta. The difference with this, though, is that your theta is measured in radians. So if I give you the angle of something in degrees, we need to convert that to radians first. Now, the piece of it, so the area of it, is r squared times by theta divided by 2. That's how I write it. They have it as 1/2, but I find that if I write 1/2, you guys start to cringe up because it's a fraction, even though 1/2 is the same as multiplying it by 2, or dividing it by 2. Okay? So what I'm referring to on that particular thing was this part right here. The stuff that you ate. Like if you were a non-crust eater for pizza, the area would be what you consumed, and the crust would be the arc length that you left behind. Okay? Just so that you guys are aware of that. That's what that would be. So as far as that formula goes, here's what they're going to do for you, is they're going to give you, find the arc length and the area of the sector with the given radius and the central angle theta. And it says R equals 4 inches, and theta is equal to pi over 6. If I give it to you as pi over 6, am I in radian measure right now? Yes, I am. The reason why I know it's in radian measure is because I got the pi symbol in it. That's how you know. Okay? So if I want the arc length, what did I give you as the formula for arc length? Huh? No. S equals R times theta, right?
Yeah.
That was the first formula I gave you.
I didn't see that one. Is it that on arc length?
Arc length. I know.
Wait, so is SR though?
Yes. No. Yes. So what's the radius? 4. What's theta? So when I multiply that out, I got 4 pi over 6, which ends up reducing down to 2/3 pi. That's the arc length. Okay, I don't think it says anything about what to round it to, so I'm going to leave it in terms of pi, unless it tells me that. Okay. Then as far as the arc, or the area of it, I've got r squared theta divided by 2. So I got 4 squared times pi over 6, all divided by 2. What's 4 squared? 16. Okay, 16 pi over 6 reduces down to what? Eight pi over 3. Maybe we should have had it as times. No, I can't.
But we did the area there, so.
Maybe I should have wrote it as times 1/2. Because remember, timesing it by 1/2 is the same as multiplying or dividing it by 2.
Why do you put it to the 6th?
Hmm?
Is that?
I put that's the,
Oh, okay. But
and then the
where
4 was the radius.
yeah, but where did you get that part?
That's for this formula.
Okay.
That's for the crust.
Okay.
So if I multiply that one out, I got 8 pi divided by 6. What's 8 pi divided by 6 reduced to? What's 8 over 6 reduced to? 4/3. Thanks, Fallon. And I can't put a 3 in that corner, apparently. I know.